Hello, welcome to the carbohydrates review. This lecture is certainly going to be more comprehensive than the content of your book, and that's for a very good reason. If you're in this class, presumably it's because you are intrigued, you are interested, you are curious about nutrition, and hopefully by this point in the course, there's been enough information that you've encountered that you're really starting to get interested and you want to know more. So this will certainly be one of the longer lectures, but I think that you're going to find that this is incredibly insightful and educational. And so I'm going to try to speak quickly, but hopefully not too quickly. And hopefully you're able to focus. You don't have any distractions at the present time, and you can really tune in. Be sure that you hit pause at any point and click your cursor back to drag the video back if you need to hear something again. Don't rush through this. You can even listen to part of it, and if you remember where you stopped, you can come back at a later time and complete the rest. So let's get started. First things first, you need to know what is not correct. We're going to come full circle here, so I want to make sure that I start out by pointing out things that you may be mistaken about if you're like most people. There is no food group called carbohydrates. You hear people all the time say, I don't eat carbs. Well, that doesn't make sense. That's like saying you don't eat an entire class of nutrients. You know there's 6 classes of nutrients. That would literally be impossible since all foods except eggs and meat contain carbohydrates, and people constantly mean certain foods when they say carbs or carbohydrates, but carbohydrates aren't foods. They're a nutrient. It is not correct that sugar's bad. The word sugar is just as misused as the word carbohydrate. Sugar is one of 3 structural forms of the chemical called carbohydrate. Remember, nutrients are merely chemicals. Sugar does not cause diabetes, so not only is it not bad for us, but eating it does not cause diabetes. And hopefully right now your eyebrows are raised and you're thinking, what? Which means I have your attention. It is a myth that people with diabetes should avoid all forms of sugar. I have to tell you, as a registered dietitian, one of my favorite things when I encounter someone, a new patient, and they have diabetes, is to say to them first and foremost, I hope you didn't come to see me because you want to hear about what you can't eat, because I prefer to teach you how you can eat everything. Needless to say, people are then intrigued and they stick around. So again, hopefully you're focused, you have no distractions, you're really listening so you don't miss anything here, so I can clear up confusion and I can provide clarity. You want to be taking notes. This is going to help you immensely, certainly for the class purposes, certainly for your professional pursuits, and hopefully on a personal level. So as you look at the pictures that are appearing on the screen, what are you seeing here? You're seeing foods. And at this point, I hope that you are clear on the fact that foods are large structures that are merely comprised of mixtures of nutrients, water, vitamins, minerals, proteins, fats, and carbohydrates. None of the things you see here are made of just one nutrient like carbohydrates or just protein or just fat, and certainly none of them are just water or just vitamins or just minerals. They are all complex packages that consist of a multitude or a mixture of nutrients, and that's what makes these foods that nature has created so incredibly valuable to the human body, because you're getting a plethora of valuable nutrients when you eat these beautiful foods. What do they all have in common? Well, one of the things that everything that you see here has in common is that they all contain the macronutrient carbohydrate. Every single one of them. So let me say it again because it bears repeating. All foods except meats and eggs contain carbohydrate. And yes, when I say meats, I'm including seafood. We group those as the same. So think animal flesh or dead animal, whatever floats your boat, whatever you prefer. So eggs and meat slash seafood, one and the same. All foods except those two categories contain carbohydrate. So you learned about these 6 classes of nutrients. At this point, my having said it again shouldn't have even been necessary because hopefully you understand this very well. And so we are going to go on a journey where we touch on each one of these categories in this class. And right now we are starting with carbohydrates. Biggest myth or misunderstanding really stems around the fact that people go around saying carbohydrates are bad, I don't eat carbs, carbs are fattening, this sort of thing. And that's because people are not educated scientifically. Remember, nutrition is a science. It's not a matter of opinion. It's not something that constantly changes. It's some pretty well understood science. Sure, there's a lot we don't know, but we don't even know what we don't know. So what is known is really not debatable. But you live in a world where many people have motives for taking information out of context or only sharing tidbits with you because they know what you don't know and they can therefore influence you. Why would they do that? To sell a diet, to sell a magazine, to get you to watch a TV show. TV shows, incidentally, get paid by advertisers. Advertisers want to advertise during shows with large audiences. How do you get a large audience? You say all kinds of new and exciting things. But the reality of it is, there's not that much that's new and exciting. These are the basic facts. So what I find amazing is that getting back to the basics is new and exciting. So here's what you want to know. Without adequate carbohydrate intake, the body's cells cannot function properly. Remember, you're a giant cluster made up of trillions of cells, and each one of those cells needs fuel. Without adequate carbohydrate, which is your body's primary and preferred fuel source, the body is going to be forced to eat itself. That's its starvation mechanism. That is what has allowed man to survive throughout all of history, because throughout most of history, food has been unreliably available. There have been periods of scarcity throughout the year for all of mankind. And so the body knows, in a period of scarcity, I can eat myself. Hopefully you don't think that sounds wonderful, but it's wonderful that our body can do that. It means we're an amazing piece of machinery, but it's certainly not something that we want to encourage unnecessarily, right? We want to keep our stores and not eat ourselves if we can help it. We're going to come back to that. Also, another big myth or misunderstanding that carbohydrates are something we should avoid. I just am floored every time I hear people say this, and I think, what it tells me when I hear people say that is that they're not well educated. And as a registered dietitian, who is the professional with the most expertise in nutrition and having a particularly high level of education in the subject matter myself personally, I happen to know a lot more than a lot of other people that I encounter. So I know what they don't know. Here's what most people are unaware of. All plant foods contain carbohydrate. Think about the pictures you just saw on the screen. They all were plant foods, with one exception, which we're going to come to shortly. Plant foods are the healthiest foods we can consume. That point has been reiterated in the first 2 chapters themselves in the book, on your assignments, and in the discussion board conversations. And that is one thing that scientists from all angles will agree on. Plant foods are the healthiest foods that we can consume. You'll know more about that as we progress and by the time you complete this course. Another myth or misunderstanding: carbohydrates are not fattening. Guess what? Protein can be fattening. Fats can be fattening. alcohol can be fattening. So everything that contains calories can be fattening, but there's nothing special about a carbohydrate or about protein or about alcohol or about fat that makes it fattening. The one thing they all have in common is what you already know. They all contain calories. 4479, right? And when we take in more calories than our individual body uses in a day, it says, thank you for this emergency surplus supply. I'm going to tuck it away and store it. And there's only one way to do that. The body stores extra fuel reserves in what is formerly called adipose tissue, which is what you call body fat. Again, since the beginning of time, this has been the mechanism by which we could survive. We would eat as much food as was available when we could get it, and that way we took in extra calories. They were stored in the form of body fat, and then when less food was available, our body could eat itself, could quote unquote, as you would say, burn up its body fat stores. Survival. So we have to start with some basics. And I told you at the beginning of this course that this is very much a science course. And I have tried in other instances over the years to explain things to people much more briefly, and then I find that they're confused later. So I find that when you leave out too many things, people don't easily connect the dots. So I'm attempting to be a little bit more in depth here, but still keep it as basic as possible for our purposes. So one of the most basic things that you may have learned somewhere in your kindergarten through 12 education is the concept of photosynthesis. In essence, what this means is that the plants in our world, trees, shrubs, bushes, and otherwise, are capturing the sun's radiant energy in a storage form called carbohydrate. Hence, all foods contain carbohydrate. So literally, the water that's being absorbed through the plant roots, whether it's vegetables and fruits or nuts and seeds or grains or legumes, all of which are plant foods, that water, we all know water is H2O, is made of hydrogen and oxygen. And carbon dioxide from the environment is absorbed into the plant's leaves. Hopefully you've heard of CO2. So you see, this is chemistry, right? I told you all nutrients are chemicals and that science of nutrition is all about chemistry. Chemicals are what our body uses, and chemicals come from nature in many different ways. So plants capture carbon, hydrogen, and oxygen. And together, the chemical abbreviation is CHO. So that is the abbreviation for carbohydrate, a chemical structure contained within all plants. There are actually three forms of this chemical structure called carbohydrate contained within all plants. Some of them are in a form called sugars, some are what we call starches, and some are fiber. And you will generally find all three forms of carbohydrate within one given food. Some foods might have more of one type and less of another, but you're rarely, if ever, going to find a food that doesn't have all three forms to some degree, because it's all carbohydrate. So as you picture this leaf and you imagine the fact that this leaf has structure, it has rigidity, it has shape, it's not a pool of liquid, right? And so how does that happen? Well, it's because these structures are giving it rigidity. So if you just have a bunch of loose little singular balls like what you see there, the saccharide molecule, there's not going to be any way to create rigidity to the leaf and to give it structure. But when they link together, it becomes taut and rigid, and it forms different structures in the plant. So you have singular molecules, which are formally in chemistry called a saccharide. You would just call that a little sugar molecule. And you have larger saccharide structures where they link together. So the first form, sugars, simply refers to a structural form of carbohydrate, either a monosaccharide or a disaccharide. Now, hopefully, common knowledge tells you that mono is one and di is two. So a single saccharide molecule that's not linked to any others is a monosaccharide. And if you link two saccharides together, well, it's a disaccharide. What we can certainly agree on is that these are very simple structures. So in nutrition science, we just call them simple carbohydrates. Not much has to happen. If I consume a plant food that contains a monosaccharide, well, there's nothing to break down. It's going to be absorbed very easily into my blood. If I consume a food that contains a carbohydrate structure called a disaccharide, there's just two little molecules. It's not too hard to break them apart. It's a very simple process. It's a very simple carbohydrate I'm eating. And again, it goes into my blood very easily. That's fabulous because it means it's very easy for me to get the fuel that I need. In everyday terms, we don't go around talking about monosaccharides and disaccharides, though when we're talking about these little simple structures, we just say sugars. So that's what you need to be thinking about. The first form of carbohydrate called simply sugars. Now, sugars can occur within foods from nature, right? They're in all plant foods. And so while there are other forms of carbohydrate in these plant foods, starches and fibers, there are also singular sugars. And nature did that on purpose. Nature said plant foods are the easiest foods to obtain. You don't have to chase them. You don't have to slaughter them. You don't have to dismember them. You just got to grab hold of them when you find them and eat them. And so throughout all of mankind's history, plant foods have been our most readily available food source, hence gathering. You've heard of hunters and gatherers? Well, gathering's a lot easier than hunting. And so nature provided for our needs. Nature said you need carbohydrate. It's your body's primary fuel source for its trillions of cells, and we don't want your vehicle to run out of gas or it'll go kaput. You'll die. So here you go. Here's nature's bounty. Here's your fuel in the form of naturally occurring sugars in nature's whole foods. Fruits, vegetables, legumes, grains, and so on. What makes these even better is that none of these, right, just contains carbohydrate. Again, nothing just contains one nutrient. When you eat these amazing whole foods from nature, you're getting a wealth of valuable nutrition. You're getting a whole package from these things. You're getting vitamins and minerals that we're going to talk about later that are so important to the function of your body. You're getting protein from all of these things. Yep, they all contain protein too. Most of these things have some amount of fat. Some have more or less, and they have different types, which we're going to talk about later as well. And they all are made of water. Water is essential in the formation of any structure, and water is essential to the health of the body. So not only do you get the 6 classes of nutrients when you eat these whole foods, one of which is carbohydrate, but you also get another chemical we're going to be talking about. Phytochemicals. Phyto just means plant, so phytochemicals are plant chemicals. So all of these plant foods have all 6 classes of nutrients, plus these things called phytochemicals that have immense benefit to human health. So I don't think I can say it any better than to simply say plants are where it's at. Now, sugars can also be added to foods. How are they added? Well, they're added at the table. They're added in food preparation when we're cooking. They're added at the manufacturing level. They get added to foods in all sorts of ways. People oftentimes want to talk about the differences between added sugars as if any added sugar has benefit. The reality of it is that added sugars offer you nothing but fuel. Now, if you need that fuel because you personally have a greater need for fuel than the next person, and this is how you choose to get it, then that's an option. But remember, these aren't part of a larger package. When you take in added sugars, you are taking in pure carbohydrate, just fuel. It doesn't matter if it's honey. It doesn't matter if it's maple syrup. The debate is not where the added sugar originated. The issue is what does it bring to the table? And what it brings to the table is function in some ways. We're going to look at the culinary science of that, and flavor, which is important as well, because that's an element of pleasure, and food and dining should involve pleasure. But too many of these added sugars are a big problem, and they have become very prevalent in our food supply today. So I'm sure many of you have heard all the things about honey, so let me just simplify this for you. Sure, honey came straight from the beehive. Nature created it. But guess what? White sugar, sugar in the raw, brown sugar, molasses, maple syrup, they all came straight from nature too. White sugar and brown sugar are either made from beets, sugar beets, or sugar cane, both of which are plants. They're just dehydrated, and then they end up getting bleached or not, and that becomes granulated. Maple syrup, that's processed too. So we have to process everything to make it safe. Nobody goes out into a forest, finds a maple tree, and latches their lips onto the tree and sucks the maple syrup out of it. We take it and we distill it and refine it, and then we package it. And most of us don't eat honey that hasn't been pasteurized. For that matter, most of what we're buying has been, and even if it hasn't been, again, you're not latching onto a beehive and sucking the honey out. You're adding it to foods. There are certainly some things that could be contained within honey that are beneficial, but the amount of honey that one would have to consume to truly derive any benefit from it is a much larger quantity of honey than would be wise in the interest of the fact that it's nothing but calories that most of us don't need. So don't try to justify honey. Say, okay, I'm going to use some added sugar. I guess if I have to choose one, maybe I'll choose honey just because there might be something positive in there. But don't assume that honey is naturally oh so healthy. That's really taking things out of context. So there's room for both, right? There's room for all these amazing naturally occurring sugars that are contained within whole foods that therefore are part of a larger package that's hugely beneficial to the functioning of our body and its health. And there's room for some added sugar. We want to have some fun in life, right? And so we don't want to deprive our body of carbohydrates because we don't want it to eat itself. So we just need to be sure that our total carbohydrate intake is within a reasonable range. That doesn't require counting any kind of grams. The first thing you would have to know is exactly how many grams your body needs, and you would need a professional, a registered dietitian, to calculate that for you. And then you would have to learn how to know how many grams are in everything, meaning things that don't come with labels, since after all, things that don't come with labels are typically the healthiest foods. Well, no two oranges have exactly the same carbohydrate content. No two peaches, no two apples. It's all just estimates. There's no way to know exactly how much carbohydrate you take in, and even when we tell you how much you need, it's just an estimate. There's no perfect science to any of it, and it really does make for a rigid daily routine if someone's trying to track all that. It's much easier when you keep it simple and you think, what are the foods that are most health promoting? How do I get the biggest bang for my bite? I'm going to focus largely on nature's creations, and I'm going to eat mostly plant foods, and I'm not going to use a lot of added sugar. And when you do that, you get the amount of carbohydrate you need, and you rarely get too much. You rarely get too much carbohydrate, too much protein, or too much fat when you eat in a healthful manner. More to come. So added sugars have their place. There's certainly some room. We don't want to live like we're some sort of sugar Nazis, right? We want to enjoy fun. That's part of our psychological wellness. Deprivation is not a healthy psychological state of mind, nor is excess. It's all about balance and moderation. Added sugars are important from a culinary standpoint. Scientifically, in a nutrition science or a food science perspective, they're necessary in many cooking processes. For example, bread will not brown and form a crust without the presence of some added sugar. Added sugars are primarily about increasing sweetness. We do want that to increase palatability of some foods. Now, we live in a culture where we add sugar to a lot of things we don't need to. Prime example, peanut butter. When you buy peanut butter, you should see the oil separating out at the top in the container because that tells you this is not highly processed. The peanuts were smooshed and packaged, so it was processed, but you want it as minimally processed as possible. And when you find those with the oil separating out of the top and you check the ingredients and you see nothing but the word peanuts, maybe a pinch of salt, then you know somebody smushed some peanuts. They took a whole food, they lightly processed it by smushing it all up, and therefore it contains the whole wealth of valuable nutrients. But when you start to see that they've added sugars or other oils, they're trying to doctor it up. They're doing that to make it more shelf stable, and they're doing that to increase the appeal when you taste it, because the yummier it is, the more you eat, and the more they'll sell. Well, that's fabulous for them, but not so great for you, right? So when we limit our intake of added sugars by choosing foods with less or no added sugar, we keep ourselves from being as inclined to overeat, which means that we are not going to have to struggle and worry as much about weight management from a calorie standpoint. But it also means we're choosing the foods that are the most healthful for the function of our body. So biologically, you have an innate desire for sweetness. Think all the way back. Picture a caveman and everything before and after that. Throughout most of history, until 100 years or so ago, when mass farming production became viable, most people struggled to get enough food. People had to know how to grow their own food. Before that, they had to be hunters and gatherers and rely on nature and whatever mood she was in and what might be available. And so when we were out looking for food, our innate mechanisms protected us. If something was sour, we weren't going to eat it. That could mean that it had spoiled and we'd get sick. If something was bitter, that might mean it's poisonous, so we wouldn't eat it. If it was salty, we would want it, and by getting more saltiness, that would make us thirsty, which would ensure that we hydrated ourselves properly. And when something tasted sweet, our biology would trigger us to want more. And that way, we'd eat and eat and eat when food was available and store up excess calories so that when we hit that inevitable period of food deprivation that always came, we would have those body stores to feed off of. But what has changed? Our world. You live in a world where those periods of deprivation never come. In fact, we have more food available to us than we could even possibly consume, and we need less fuel than ever because we are less physically active than we ever have been in history. So think about that. Every time you put something sweet in your mouth, you trigger your biological mechanism to want more and more and more. So whether you're using added sugars or you're using artificial sweeteners, triggering that sweet taste and that desire creates a yearning for more. So when you minimize your intake of sweetness, your palate adapts and your body adapts and you crave it less. So sometimes we have to say, you know what, I want to do what's best for me rather than satisfy instant gratification so that I can be more healthy. It does take some deliberate decision making in today's world. We live in a world that's harder to live in than ever before. There's some irony to that, no? So, in terms of cooking, from a culinary aspect, obviously adding sugar creates a sweetness that is oftentimes necessary. It aids in the creaming process. This is why if you're baking something, you're always told to cream the shortening or the butter and together, right, with the sugar. It creates softening of spreading action, so it does help make things more spreadable. It promotes good grain and texture in our breads. Like I said, it has a lot to do with forming the crust. It also has a lot to do with the chemistry of the overall texture of the bread. Sugar attracts water, and so it helps foods to retain moisture, which keeps them fresh longer. Again, you can think of things like baked goods. I already said it imparts an influence on the crust. It aids in the fermentation of yeast, again, baking related, and it balances acidity. For example, think about a marinara sauce or spaghetti sauce or something with a lot of tomato content. You always need to add a few pinches of sugar to balance that acidity, right? So there are many functions that are of value. Knowing this, knowing that there will be some added sugars that are part of our everyday diet, that makes it all the more important to acknowledge the fact that we have to limit the ones we can, such as those in highly processed foods, or that we're adding directly to things like beverages. So we've looked and studied this before, and so now we're kind of connecting some dots, right? When you learned about the nutrition facts panel, you learned that the total carbohydrate line could be ignored. I told you this represents all three structural forms of the chemical macronutrient called carbohydrate, and that we could ignore that line because there's no reason for anybody to go through the day counting grams of carbohydrate. Again, a person would have to know exactly how many they need and would have to know exactly how many are in things that don't contain labels, and then would have to measure out their intake of foods that do contain labels, and oh, what a life we would be living. How joyless our days would be. So there are opportunities for this line to be useful, which is why it's here. And at the end of this lecture, I will briefly touch on the value of this line to only one group of people, and that is individuals with diabetes. Those individuals have to be properly trained, and I find that I encounter many people with diabetes who say they look at this line, but they honestly really don't know how to use it. There's an art and a science to it. So for our purposes, most of us can just skip right over this line and not worry about the total carbohydrate content. As you look at the bottom, you know that that's the cheat sheet area, right? So if you're in the store and you go, well, okay, this had 13 grams of carbohydrate, but how many should I have in a day? Well, you could look down there and it gives you an estimate around 300 grams a day. Hence, one serving of this food gives you about 4% of the daily recommended intake of 300 grams. But it's not an exact science. Everybody has different needs. You may have more or you may need less. Again, why use that? When we are focused less on those details and more on the big picture, we amazingly start to realize that everything balances out. Now, when you look down here and you go, well, what about the sugars? I wanted to look at the sugars. Well, how much sugar should you have in a day? You look down there and you go, oh my goodness, there is no line that tells me how much sugar. Well, how much sugar should I have? Well, I don't know. If you don't know, then how are you going to use the sugars line? And that's why I told you previously, the sugars line on the label is useless information. There is no percent on that line. Think about what you learned before. You learned that there are daily recommendations for what we should take in for each nutrient. Some of them are about an adequate intake. Some of them are about the recommended daily allowance, how much we should get, and some of them are the TUL, the tolerable upper limit, as in don't take in more than this amount. So you know that that bottom little cheat sheet is a summary of those recommendations. So if there is no recommendation at the bottom of the label for sugars, then you have no way to know how many grams of sugar you should take in. So no matter what you see on the sugar lines, 0 grams, 4 grams, 40 grams, if you don't know how much you need, then how in the world could you decide if that number of grams is a little or a lot? That's why we use percentages. Remember, we say there's this percent of the total recommended daily intake contained within one serving. But there's no percent on the line because there is no recommendation for total daily grams of sugar. It doesn't exist. So that's why I taught you that you have to evaluate the ingredients list and look to see the added sugars in that list. You learned that ingredients are listed from most to least. So if there is any form of added sugar within the first 3 ingredients, that is really, really bad news. You may not want to choose this item because it is made largely of added sugar. And if there is more than one in the entire list, well, I wouldn't even give it a second thought. I would put it back on the shelf instantly. Me, I'm going to put it back on the shelf instantly if there's one within the first 3, because that means it's largely made of sugar. Obviously, if it's a dessert, then it's a moot point, and I'm occasionally going to eat a dessert. But if it's not a dessert or a rare and occasional treat, I'm not buying anything with sugar in the first 3 ingredients because I'm not trying to buy things made largely of added sugar. They're not healthful choices. And if I see more than one in the whole list, then man, really, why am I choosing this item? So you learned that the first thing to do was look at the sodium just because it's often another relevant element. But you always have to check out the added sugars as well. So these are the words that were a sampling, because Lord knows there's more, of terms that mean added sugar. And if you see them in the ingredients list, then eek, you want to be concerned. Why? Why are we concerned about these added sugars? Well, again, they are nothing but fuel, calories, and many of us don't need much fuel in a day. Most of us easily get more calories in a day than we need simply because we live in a world where food is readily available, it's affordable, it's accessible, and we tend to be tempted in every direction, and so we often eat more than we need. We also tend to choose things that have a lot of calories in a very small package because we eat a lot of highly processed things. We eat a lot of prepared things. We eat a lot of things that don't really have a lot of health promoting qualities, and those tend to be the foods with high calories and few nutrients. So we should be worried about our teeth, for one, because we've all been aware most of our lives that a lot of sugar causes cavities. But you also want to know that when you're taking in a lot of added sugar, it's raising the levels of a blood fat that is called triglycerides. Because when you take in a lot of extra sugars, not from plant foods, but from added sugars, sugary drinks, sweets, treats, and so on, then those added sugars are processed in your liver and packaged into these little fat molecules called triglycerides that then float around in your bloodstream and cause damage throughout your blood vessel system, leading to many diseases. Those added sugars are also creating a lot of inflammation. If you banged your hand, it would get inflamed, right? So imagine all these things banging around on the inside of you causing inflammation. Clearly, that's not a healthy state of being. The one little tidbit I want to share with you is that it is a long-standing myth that eating sugar causes hyperactivity. People always go, oh, the kids had a bunch of sugar, they're so hyper. Fascinatingly enough, scientific research on this very point has been conducted exhaustively, and there's no consistent correlation between sugar intake and hyperactivity. Most of the times when kids are getting some sugary treats, the environment is conducive to hyperactivity. It's some sort of a fun event. Plus, kids just have a lot of energy, especially if they're cooped up inside a lot, which is pretty common in today's world for a variety of reasons. And so I could go on and on about that, but I just wanted to share that with you because that's, I find, something that most people are really surprised to hear. So, let me share with you some current news in today's world. For quite a few years now, there has been an effort by a particular consumer advocacy group to try to get the food label changed again. It wasn't until 1990 that there was a nutrition facts panel. So since then, there has been an effort to try to improve upon it, and there has been a lot of resistance. Legally to change a law, you have to fight for that. And food companies fight against things that aren't in their interest. And the more information they have to reveal on a package, well, the less likely people are to buy it if it's not so great, right? So they have pushed back. But a law has been approved that will require that all companies begin to list added sugars. They are not yet required to have this. They have something to the effect of 2 years, maybe it's 3 years, but I've noticed that many companies are beginning to go ahead and implement this. So as you're shopping these days, start to pay attention to the nutrition facts panel and see if you can find one that looks like the new label on the right. So again, on the left, we have the traditional label that still exists on many packages, which just lists total carbohydrate, fiber, and sugars, and we know that total carbohydrate and sugars are useless lines on the label. But if you look at the right, then there's an additional line, and it says includes X grams of added sugars. Well, there's no daily recommendation, as you know, for total grams of sugar. But there is a daily recommendation for total grams of added sugars. So total grams of sugar means all naturally occurring sugars plus any added sugars. And you have no idea how many of those grams came from naturally occurring, which are good, as opposed to added, which we want to limit. But when they have to explicitly tell you how many grams of added sugar are in the contents, that's useful information. So the recommendation is that we not consume more than 50 grams of added sugar a day. That's actually not a lot. It adds up very quickly. So if I were to look at the label on the right as a shopper and I were to use the percent evaluation 5, 10, 15, 20 that you've already learned, and I looked at the added sugars line and saw 20%, I would go, I know that 20% is high, and a high amount per serving of something that's not in the interest of my health makes it a bad choice. Again, unless I was purposely seeking out a treat and I wanted to splurge, this would not be a good choice. So now you understand sugars. Let's talk about the second form of carbohydrate, starches. Remember, we say sugars and we simply mean a structural form of carbohydrate. Same thing with starches. So while our sugars were either singular monosaccharides or two little saccharides stuck together, disaccharides, both of which are very simple structures, hence simple carbohydrates, starches are more complex. They are linked chains of many saccharide molecules. Poly means many or multiple. So this could be 100 of these sugar molecules linked together. So being that it's a much more complex structure, we refer to a starch as a complex carbohydrate, a complex chemical structure known as carbohydrate. But we don't go through life usually talking about polysaccharides or even complex carbohydrates. We usually just say starches. As you look at these images, remember they're all plants, and you know that all plants contain carbohydrate, and you know that where there is one form of carbohydrate, there are all forms of carbohydrate to some degree. So all of these plants contain sugars and starches. And that's really a great thing because we can eat the plants and get the fuel we need for our trillions of cells. So these polysaccharides, these complex carbohydrate structures made up of multiple saccharides, will be broken down when we eat them. So if we eat one of the foods here, then as we chew, some of these are broken apart. As it reaches our stomach, the acids and chemicals in our stomach start to rip these long linked chains apart. And as our stomach contents empty into our small intestine, more chemical action takes place. And the muscular contractions squeeze and break the food up and break all these complex structures apart into little singular saccharides or sugars. Now, there is a third structural form: sugars, starches, and now fibers. Fibers are also polysaccharides, long linked chains of sugar molecules. They are complex structures, so they are complex carbohydrates. But fibers are different from sugars and starches in one unique and meaningful respect. Let's take a look. Unlike sugars, which are very simple and easily pass through our stomach and into our small intestines and then go across the walls of our small intestines into our bloodstreams, and starches, which easily get broken down and enter our bloodstream as they cross the wall of our small intestine, fibers cannot be broken apart by the human body. The body cannot digest them. Digestion simply means breaking things down. So fibers stay intact and they pass through the gastrointestinal system. They enter the mouth. They are a part of foods that are traveling down the esophagus into the stomach. In the stomach, they remain intact. They pass into the small intestine and then the large intestine, and they remain intact. And then they leave our body in a bowel movement in our feces. So they're remarkable in that this is one particular form of carbohydrate that's in all plant foods that we cannot digest. So if we can't digest it and absorb it, we have to wonder, does it have any value to us? Sure it does. It has loads of value. We already know plants are where it's at and that there are many, many reasons for that, one of which is that they provide fuel for our cells, but another is because they provide carbohydrate in the form of fiber, which has lots of great benefits. We've all said, oh, I need to eat more vegetables to get more roughage, right? Well, that's just one perk. Think about what you know. You know that the macronutrients, carbohydrate, protein, and fat contain calories. You know that carbohydrate contains 4 calories per gram, and you know that fiber is a form of carbohydrate. That means fiber contains 4 calories per gram. But if we can't break it down, then we can't absorb it, which means we don't absorb the calories. That means that when you eat foods that are high in fiber, you can eat more food and get fewer calories. Fiber's like magic. Again, all plants contain fiber. So, a quick recap. Sugar, a single glucose molecule. If two of them stick together, it's still a very simple structure. It's just two singular molecules stuck together. In either case, they are simple carbohydrates. A starch, a long linked chain of glucose or sugar molecules, a very complex structure. Same thing with fiber, a complex structure. So the three forms of carbohydrate in food that we will refer to throughout this course are sugars, starches, and fibers. There is an exception to all of this plant talk. Animal milk is the exception to the rule. Remember, animals have boobies, and if it has a boobie, it can produce some milk. Have you seen an almond with a breast? Have you seen rice with a breast? Have you seen soy with a breast? No. So while all those things can be used to make a liquid beverage that mimics milk, it is not the same thing. Those are alternative beverages because they can be used as an alternative to milk, in that they will behave the same way. They will still wet your cereal in the same way. Some of them will still function in baking or food production methods in the same way or a similar way. But that doesn't mean that they are the same thing. So we're clear. So what I'm talking about here is mammalian breast milk, which comes from a live animal, whether it's a cow or a goat or a sheep, and so on. If an animal is living, then it has a pumping heart, which means that blood is circulating throughout its body. And people are animals just like these, so you understand that people have sugar circulating throughout their body and their blood so that it gets to all their cells to keep them alive. Same thing with every other animal. That means that if you extract the breast milk, a body fluid, from a living animal, it will contain all of the chemicals that are in the blood, because the blood has been delivering those chemicals to the breast tissue so that they can become a part of the breast milk, so that those nutrients can then be passed to the offspring who consume the breast milk. Whether it's a woman or a cow, it's exactly the same situation. So if there's carbohydrate in breast milk because there's sugar in a living mammal's blood, then that means that there are naturally occurring sugars in mammalian breast milk. So most of us probably are inclined to drink cow's milk over any other animal milk. So that's what we're tending to focus on throughout this course. But if you drink goat's milk instead, just substitute that. So all plants plus milk contain carbohydrate. That means all dairy foods contain carbohydrate, right? Cheese is made out of milk, yogurt and kefir are made out of milk. So anything that's dairy is a milk product, and anything that contains milk contains carbohydrate. Oops, let you take that in for one moment. Now, you've heard me state repeatedly, now and previously, that there is no carbohydrate in meat and eggs. I've said repeatedly, all foods except meat and eggs contain carbohydrate. Can you understand why that is? Again, living organisms have a heartbeat. A heartbeat means that blood is being ejected from the heart so that it travels through that organism's circulatory system in an effort to deliver the contents of the blood, nutrients, oxygen, and otherwise, to the trillions of cells in that organism's body. If something is dead, it does not have a heartbeat. Therefore, there is no blood circulating to its tissues, and its tissues become deprived of all nutrients. So when we eat meat, what are we eating? We're eating a dead animal, one without a beating heart, one without any circulating blood. Whatever nutrients had been delivered to those tissues are slowly breaking down, because that's what happens when a living thing dies. Eventually, everything decomposes and you have a pile of dust, right? Which is mostly minerals, actually. So, yeah, we're eating dead animals, which means there's no circulating blood, which means there's no carbohydrate in their tissues. How about eggs? What's an egg? Well, it's supposed to be the developing fetus of a chicken, right? It's supposed to be a developing baby. Well, if you live on a farm or you have access to a farm where somebody has a hen house and you get eggs directly from that source, then you could crack one open and see a partially developed fetus, because that's how those eggs came to be, most likely. But here's the fascinating thing. If you know the story of the birds and the bees, then you know how conception takes place. Well, a chicken doesn't need a rooster to lay an egg. A chicken only needs a rooster to fertilize an egg. So if a chicken and a rooster don't hook up, then that chicken can still lay an egg and we can still eat it. But because it was never fertilized, there's no way that a fetus would ever have begun to develop, in which case there was no circulatory system there, and then therefore there's no carbohydrate. And the eggs that we buy in our stores are unfertilized eggs. So the majority of the eggs you will encounter in your life are unfertilized and therefore don't contain carbohydrate. How you doing at this point? Do you need to take a break? Like I said at the beginning, this might be a good stopping point. You come back later, you come back tomorrow. Hopefully you're finding this interesting, but I realize it's a lot. So just giving you a chance to decide what to do before we proceed. All right, here we go. Let's start with this point. Carbohydrates are not bad. Hopefully you now understand. Without adequate carbohydrate intake, the body's cells cannot function properly and the body is forced to eat itself. What you can now understand based on what you know: 4 calories per gram of carbohydrate. You know that. You know that calories are the energy for our trillions of body cells. You know that we each need a certain number of calories each day for our body to function. We have not discussed how you might determine how many calories you need for your body, and we're not going to do that because, as I said at the beginning of the course, in the very first lecture, the focus here is not on calories. The focus here is on nutrition. And when one establishes good nutrition, calories tend to take care of themselves. But the reality is that we have to eat enough food to get the calories we need. And the reason we want to eat some carbohydrate is to get many of those calories. In fact, most of our daily calories that we need should be in the form of carbohydrate, because we need sugars, starches, and definitely fiber. Our body is designed to operate as a really efficient piece of machinery because our body is designed for one purpose: survival. Suppose you could say it's designed for a second purpose, procreation, but we had to survive in order to be able to procreate, right? So your body has all these mechanisms in place. It says, if you give me carbohydrate, it's easy for the cells to take it up and get the fuel that they need. I can make fuel from protein and fat, but it's much harder to do, and I really prefer to use those for a lot of other valuable functions as well. So let's make sure you give me most of my calories from easily usable carbohydrate, and then get me some of my calories from fat and protein, because I can use fats and proteins for other things too. So all of those digestible and absorbable carbohydrates, your sugars and starches, are absorbed into your bloodstream. Once they've reached the small intestine, they pass through the walls of the small intestine and they enter into your bloodstream. There is a special mechanism by which your body can store a little bit of glucose in your liver and skeletal muscles, and I'll come back to that point. So let's revisit what you learned in the anatomy and physiology video. This is the digestive system, right? All of these organs you see here make up an entire body system called the digestive system. And when we look, the beginning of it is the mouth, then food passes through the esophagus, then it goes into the stomach, then it goes into the small intestine, then it goes into the large intestine. Whatever scraps there are become feces, which is held in the rectum until the point of excretion through the anus. The organs you see, such as the liver, play a role in digestion by secreting chemicals. The pancreas secretes chemicals. The gallbladder secretes chemicals, all which help us extract nutrients from food, which is why if the liver, the gallbladder, or the pancreas are damaged, it alters our ability to use nutrients properly. And if we get too many nutrients and they damage those organs, then the organs can't work properly. Balance is what good health is all about. So, walking yourself through this, ask yourself if you understand. So, at the point that the food has been digested, passed from the mouth through the esophagus to the stomach to the small intestine, and subjected to the chemicals from all those different organs that helped us break the food down and extract the nutrients, once it all gets to the small intestine, then everything's going to pass through the walls of the small intestine and enter the blood vessels that surround them so that it can circulate through the body. So you see a picture here showing you that all carbohydrates from food, sugars and starches, are in their simplest form. They've all been broken down and we have nothing but those little singular sugar molecules called monosaccharides. These are being absorbed through the walls of the small intestine and mixing with the blood in the bloodstream. Once in the bloodstream, we stop calling them sugars. Now, I know you hear people say all the time, my blood sugar. That is what people who aren't educated say. But the correct clinical term is blood glucose. So blood sugar, blood glucose, they mean the same thing. These simple sugar molecules are absorbed right through the walls of the small intestine and into the blood without delay because, like I said, our cells are eager to get the fuel that they need. So this is how it works. Those glucose molecules in your blood are awaiting transfer into your trillions of cells. So this is just like you're looking at a side view of a snippet of a blood vessel. And remember, you are nothing but a giant network of blood vessels. Every inch of your being is made of blood vessels because blood is flowing through every inch of you, delivering oxygen and water and nutrients like carbohydrate to all of your trillions of cells and removing all of the waste products that are generated when your cells use those things in a productive fashion. So think about it. If everything but meat and eggs contains carbohydrate, then every time we eat foods other than meat and eggs, they break down and are absorbed into our blood where they become blood glucose molecules, and therefore there's a larger volume of glucose in our blood, hence our blood glucose level rises. That's supposed to happen. That's how the body works. Well, when the level rises, the body gets the message, hey, there's a lot of fuel in the fuel tank. Let's move it into those cells, get it out of the blood, and move it into those cells where it can be used. So the idea is that the glucose will leave the bloodstream and move into the cells. Hence, the blood glucose level goes down. Every time we eat, it goes up. As the sugar moves into our cells as it should, it goes down. Then the body says, hey, you're running low on fuel, and triggers you to feel hungry. So you seek food, you eat, You fill the tank up, then it moves into the cells and goes back down, and your fuel gauge triggers you to seek more fuel. So blood glucose, blood sugar, constantly rises and falls throughout the day based on eating and then using the carbohydrate consumed. That's normal. This is why it matters when somebody measures their blood sugar. This is why if you go to get an annual physical, and oh, I certainly hope we all do, because that's how you prevent health problems, you keep on top of your health. If you go to get blood tests as part of a physical once a year, they will tell you to make sure you are fasting. Come in the morning, don't eat anything, because they want to know how much fuel is in your fuel tank when you haven't eaten for a long time, because it would be normal for it to be low. But if you eat something and then you get your blood tested, your fuel tank's going to be full. But if you don't tell somebody you ate and they look at a full fuel tank, they're going to think something's wrong. Why is your tank full when it should be on empty? That's how we know if a body's functioning properly. If someone with diabetes eats and then they check their blood sugar, of course it's going to be high. It would be for anyone. There are special times when people can check their blood sugar, their glucose, and it will be meaningful. But people have to be taught how to do this. So let me walk you through this. When that blood glucose level rises, because the carbohydrate from our food has moved into our bloodstream, the brain says, yo, pancreas, you're up. Do your job. Well, the pancreas has a lot of jobs, but one job is to move the glucose out of the bloodstream and into the cells, and then tell the body, hey, you need more fuel. So when blood glucose levels rise, the pancreas is stimulated to secrete a chemical hormone called insulin. Insulin, think of it as a key. Its job is to insert itself into the keyholes next to all the little doors on each one of your trillions of cells and turn that lock so that door will open. So insulin is the key that opens the doors on your cells so that the glucose can move from the bloodstream into the cell, just like you see here. Once that glucose moves into that cell, then that's where the magic takes place. Our body cells take the glucose in, and then chemical reactions take place, and bam, they produce energy that fuels all the functions of the cells. It makes your heart beat, it makes your blood circulate, it makes your muscles contract, it makes your reproductive organs work. Everything about you, every function is based on the cellular use of fuel, and fuel is derived from calories in food, hence the important role of carbohydrate. Interestingly, while the body, as you know, does not like to store excess protein or fat or carbohydrate, it normally takes all excesses of the macronutrients, the calorie-containing nutrients, and converts them to body fat, because that's the only way it can store backup fuel. There is one teeny exception. You have, again, a survival mechanism, and your body says, let me take a little bit of carbohydrate and stick it inside the liver, and let me take a little bit of carbohydrate and stick it inside the skeletal muscles. If that's a new term to you, let me just clarify. Your heart's a muscle, your blood vessels are muscles, your stomach's a muscle, but skeletal muscles are those that you think of, the ones attached to your skeleton, like your arms and your legs, right? So we're specifically referring to those muscles that you might use for movement, skeletal muscles. So I want you to think for a minute about sleeping. What is sleeping? Well, you are a living being. You're not a car. So the difference is that a car gets turned off, but a living body doesn't, right? So when you're sleeping, it's more like you put it in park and the car is idling. It's still using fuel. So if we were to go to sleep and the carbohydrate levels in our blood were to be too low, we didn't have enough blood glucose to fuel all our cells, then if we ran out of fuel, we would die. And so the body doesn't want that to happen, right? It's designed for survival. So when you're sleeping, if your blood glucose levels start to drop too low, your body sends a message to the liver that says, yo, liver, I need that backup reserve of glucose that you have. The storage form in your liver is called glycogen, and glycogen gets converted into blood glucose. So it goes out into the blood, and then it's there to provide to your cells. Otherwise, your body would have to make you wake up and go eat, and then you'd never get a good night's sleep. Think about exercising. Now, throughout most of history, no one ever had to exercise. Life required a lot of physical labor. Whether you were fleeing some sort of animal, dinosaur, or whatever it might have been trying to get you, or you were simply walking all over the place, hunting and gathering and building shelter and all of the other things that have been necessary. We, though, now have to exercise because we've engineered all that activity out of our lives, right? So when you think of exercising, what do you think of? Well, hopefully you think of increased movement. In other words, you start to use those skeletal muscles. You call upon them more so than you were. And that means your body's going to have to use more fuel to help those muscles contract. Well, your body doesn't want to use up every bit of the glucose in your blood, because if it does, the machine can't work. You'll die. So it says, okay, you're calling upon the muscles. I've got a little reserve in there. So I have some stored carbohydrate in the form of glycogen in the skeletal muscles. I'm going to convert it back into glucose and pump it out into the blood so you get the extra fuel you need while you're exercising. A survival mechanism. So these reserves in your liver and skeletal muscles are glycogen, which is merely a storage form of glucose, and glucose originally was derived from carbohydrate in food. If this doesn't make sense to you at this point, your best bet is to rewind to whatever point you think you need to and to listen carefully. I'm making this as simple as I can, but for you to appreciate nutrition, you have to know how your body works. And this knowledge enables you to differentiate between much misinformation, myth, and fad pseudoscience and reality in today's world. So, think about this. If we're not taking in enough carbohydrate to meet the needs of our cells, if we haven't consumed enough to build up our liver and skeletal muscle stores, then what happens when we start to run out of fuel? What does the body do? Does it just instantly die? Of course not. Remember, you're designed for survival. The body has desperate plans to keep you alive. Dying is hard work. So the body says, all right, you're not giving me the carbohydrate I need from food, so I'm going to have to eat myself. That's plan B. It doesn't want to tap all of its resources, so it begins to alternate between two different resources. First, the body says, do you have any fat stored on you? Because what I can do is I can start to break that fat down, and I can use some of the byproducts of that fat breakdown called ketones, and I can convert it into a form of glucose that the cells can use to survive. So in today's world, people think that's great. They call that, ooh, fat burning. I'm getting skinny. What you don't realize is that to the body, that's a pretty unnatural state to be in, because the body wants you to have fat reserves so that if you are truly unable to get enough food, you won't die as quickly. So, what I'm saying to you is some body fat is very important. There are a lot of reasons body fat's important. We'll touch on that briefly at a later point in this course. But being free of body fat is actually not a healthy state, because if you don't have some reserves in a time of crisis like illness or injury, you will not last as long. The body says, man, I don't want to use up all this fat too fast, because then I won't have the fat I need for some important functions in this body. Again, fat has a lot of important jobs in your body. It's not just something that's there and ugly. That's our modern day perspective. So the body says, let me spare some of that fat. Let me go to plan C. Let me use some protein. Protein has 4 calories per gram. I don't have a storage depot of protein like I do of fat. So the only way I can get that protein is if I rob it from the tissues that contain it. The heart's a muscle, so it's made of protein, so I can start breaking down the heart muscle. The intestines are muscles. I can start breaking down those tissues. The liver is a muscle. The stomach is a muscle. They're skeletal muscles. I'll just start breaking down various muscles throughout the body so I can extract the protein. And then from that, I can take the 4 calories and turn it into usable glucose in the blood to fuel these cells. And I'll just keep alternating between fat and protein until I get the carbohydrate that I need. So again, in our modern day world where vanity is what people focus on over health, what people experience in this situation when they deprive themselves of carbohydrate is their body getting smaller. That's because their muscles are breaking down throughout their body. That's because the body is using up its fat stores, and those two processes use a lot of fluid. So people are actually becoming dehydrated. I always find that to be the most interesting aspect. People don't realize that a lot of what they're losing is fluid, not fat, and that's A, not healthy, and B, that'll get it back. But regardless, many people are focused more on looks and health. So again, yes, this can work. It can help somebody lose some excess fat, but it is not a healthy lifestyle approach. It's an emergency mechanism. If your muscles are deteriorating, namely the muscles that are organs, then the function of those organs is compromised. I think sometimes people need to be reminded what matters most: the function of your body, your health, the quality of your life, or what we look like. We live in a pretty mixed up world, don't we? So I feel compelled to briefly comment on the ketogenic diet. I try to stay current with where people's interests lie and what's going on in the world around us, which is hard to do because there's always some new fad. The ketogenic diet is not a new concept. It is a diet that very effectively treats a medical disorder called epilepsy. It is not a perfectly healthy approach, but it is an effective approach for that disease. So sometimes you take the good and the bad together, and to save those individuals from potentially life-threatening seizures makes the downsides to the ketogenic diet worth it. For the average person without epilepsy, yes, it will promote rapid weight loss because the body's eating itself. It's resorting to its survival mechanism. And when people lose excess body fat, if they truly have excess body fat, sometimes some of their other health parameters will begin to look better. So there's always value to getting rid of surpluses of body fat. However, no one has tested this dietary approach for the long term because no one's been able to sustain it for years on end. It just has a lot of drawbacks in how people will feel, how their body will function. And the bigger concern is that because of all the foods that it restricts, it's not just taking away carbohydrate, it's taking away a wealth of other valuable nutrition components, fiber, vitamins, minerals, phytochemicals, water that are in those foods people are denying. And it's oftentimes high in foods that we know scientifically are not in the best interest of health, like a surplus of animal foods. So most people are focused on it first and foremost because they are worried about how they look. They care about their size, the number on the scale. They're not so focused on their internal environment. So all I can say to you, in the interest of being a positive role model for mental and physical health, is that if you focus on the inside first, if you attempt to live your life in such a way that it promotes the healthy and optimal functioning of your body internally, then what you do to the inside will show on the outside. But oftentimes, when you focus primarily on the outside, the things that alter it are not in the best interest of the inside. So it does take a little bit of mental adjustment to remember that health should trump aesthetics or vanity. All right, let's keep going. Sugars and starches. You know that they are fuel. But what about that carbohydrate that we said is so incredibly valuable to our health? If it's not for fuel, what's it all about? Well, those carbohydrate structures called fiber, those long linked chains of sugar molecules, come in two forms. One of them is insoluble. The word soluble means to dissolve in something, right? So your body is a very watery environment. Your blood is largely made of water. So the insoluble fibers won't dissolve into your blood at all. They stay intact. I like to visualize it like a little scrubby brush. Picture a toilet brush and the brush is on both ends. And it's going through your entire gastrointestinal system all the way to your anus, just scrubbing you out. That's a good thing, right? So it's helping remove toxins, dead bacteria, dead cells, and cleanse your system. Your body is fabulous at cleansing your system if you give it what you need, which is fiber. It has a lot of other perks too. Because it doesn't break down, it stays in our system longer. Because your body is fighting to try to break this down, and fiber is resisting. So the longer that battle wages, the longer it's in your body, and the longer it's in your body, the longer you feel full. So it helps us feel full when we eat foods high in fiber. Keeps our bowel muscles stimulated. Fiber gives bulk to your stool, to your feces. And when there's bulk to your feces, then it presses against the walls of your colon and it stimulates those muscles to flex, which pushes stuff through. In other words, you poop more, and pooping more is a good thing. The reverse is true too. That's what's amazing about fiber. It goes both ways. If somebody has really loose stools, diarrhea, then if they add a little more fiber to their diet, it will take that liquidy stool and bulk it up and help slow down that diarrhea. You know there's 4 calories in a gram of carbohydrate, but you know that if you can't break down and absorb fiber, then you can't absorb the calories. So you can eat a lot of fibery foods and not get very many calories, which helps you control your weight. And since we can't absorb this form of carbohydrate, then those sugar molecules can never enter our bloodstream and become glucose. That is really helpful to people with diabetes because people with diabetes can eat carbohydrate. They just have to regulate how much they take in. And if they had to just limit what they ate real strictly, they would be hungry. So when they eat plant foods that are high in fiber, they get the sugars and starches that become the blood glucose they do need, but they don't get too much because a lot of the carbohydrates in those plant foods are fiber that never gets absorbed. The other form of fiber is called soluble. That would imply that it dissolves in the blood. but technically it doesn't. Instead, it tries to, and it becomes this sticky, gummy paste. Envision a big blob of gum, I guess, chewed up bubble gum. And one of the perks of that is that as it's floating around in our blood being sticky, the cholesterol that's in our blood is sticking to it. And a lot of people struggle with having too much cholesterol in their blood for a lot of reasons. And so too much cholesterol can be harmful. So when it sticks to this soluble fiber, since this soluble fiber is going to pass through and be excreted in our feces, it's going to be removing the cholesterol with it. So fiber is fabulous. Fiber is in all plant foods, and you know that plant foods are where it's at. So when we're looking at a label in a store, what are we looking for? Well, you learned 5, 10, 15, 20%. And you know that 5% or less is low and that 20% or more is high. If you want a nutrient because more is better, then you want it to be significant, 15% or high, 20% per serving. So when we look at this label and we see that it contains a low amount of fiber, we should think, well, that's not a good choice because I want a lot of fiber. In fact, I want 25 to 30 grams a day. I can see that right here on the label. This has 1 gram, 4%. Not a great choice. Now, here's an unfortunate consequence of the world that we live in. Marketers know that you've heard something about fiber somewhere. They hope you don't know as much as you're learning here, though. They love to advertise things on the front of the label. Daily value, 35% of fiber, which doesn't even make any sense. Fiber 1 sounds healthy. And then they take little powdered forms of fiber that have been processed in a laboratory and they add them into the recipe mixture. So that way they can say there is more fiber. The problem is what they are adding, things like inulin and chicory root, are not the same as the intact fibers in nature's plant foods. So they're not going to have the same effects. They're not going to hurt you, but they're not going to be guaranteed to help you in the same ways. But legally, they can't lie to you. So they have to add in a bunch of fiber supplements in order to market it as being high in fiber, which plays to your ignorance. What you don't know will help them. So what are we looking at here? Let's be open-minded. Let's look at the big picture. What do you see on the front of this package? To me, that looks like a candy bar, and guess what? That's what it is. Let's look at the ingredients list. The very first ingredient is chicory root extract, which is a form of a fiber supplement. So this thing is made mostly out of a powdered fiber supplement that does not have the same benefits as fiber in plants. What's the second ingredient? Chocolate chips. Is there anybody here that's going to claim they're healthy? You can see the main ingredient in a chocolate chip is sugar. And then they go, well, our third ingredient is whole grain oats. Yeah, but that's not your primary ingredient. Just because you put a little something healthy in there doesn't offset the corn syrup and the sugar that comes later and the high maltose corn syrup and the maltodextrin and the fructose, all of these being added sugars. This is a terribly unhealthy candy bar, and it's not cheap. You could eat an apple or a carrot for a heck of a lot less money and get a lot more useful fiber. So that's why you began this course hearing about whole grains versus refined grains, which should not be new information to you, but here's some basic background. when we grow grains, and there are many types of grains, rice is a grain, wheat is a grain, corn is a grain, and so on. When we grow grains, this is what they look like. They are plants, and they have this large component that we rip from the stalk, and then we grind it up to make it into different kinds of flours to use for different purposes. So the whole grain contains the whole amount of valuable nutrients. There's the bran, there's the germ, there's the endosperm. So that outer layer is going to have some fiber and other nutrients. Those inner parts are going to have proteins and fats that are healthy for us. We're getting all sorts of valuable components, from vitamins and minerals and water to fat to protein to carbohydrate. We want the whole package because it's good for us. It delivers meaningful benefits to the function of our body. So when we're focused on these choices, we are taking in the most healthful grain options. When you're shopping in the store, though, you're not always just buying a package of brown rice, and you're not always just buying a package of quinoa. So what about things that have been made from grains, where we took these grains, we milled them, we ground them, turned them into flour, and made something out of them? Well, that's why you want the very first word in the ingredients list to be whole. And you want to see the words 100% whole. What do you think the term multi-grain means? It means multiple grains. It doesn't necessarily mean multiple whole grains. It may mean multiple refined grains. So there's nothing about multigrain that means healthy. Whole grain and 100% whole is what you want. What do you think the difference is between whole wheat and wheat? Whole wheat, they use the whole kernel. Wheat, they refined the grain, but it's still brown. Then if they take it and they bleach it, you get white. So wheat and white are both the same. They're refined grains. They are not at all the same thing as a whole grain. You want 100% whole. So when you eat plants and nuts and seeds, you're getting tons of fiber, and when you choose whole grains, you're getting a lot of fiber. Refined grains, though, tend to make up the bulk of the American diet, because when we go to restaurants, they don't usually serve us whole grains. They might serve a multigrain, but they rarely serve things made from whole grains. Why? They don't taste as good to people. People like refined grains because the sugars dissolve in your mouth, and we like that taste, and then we want more, and we say, that was a great restaurant. They had the best pasta. They had the best bread. If we serve whole grains in restaurants and they aren't as palatable, we fear that people won't enjoy our food as much and we won't get return business. So the good news is that the world is shifting. Consumers are more and more interested in healthful options. Sure, not all of them. So you got to have both. You got to have refined grains on the menu and whole grains. If you're in a healthcare institution, really it should be all whole grains. But people want options because some people, when they go out to eat, actually do care about their health. These things here, though, these cereal bars, whether it's your Nutri-Grain type bars or it's your Special K bars, your crackers, your cereals, your croissants, your breadsticks, your cookies, your white pasta, your white rice, these are the things that we need to modify if we want to promote health. Back to what nature provided, 100% whole grains. So when you're looking on the ingredients list, the first word should be whole, and there shouldn't be very many ingredients, period. So now that you understand how the body uses or processes the formal word is metabolizes, carbohydrates, you can understand that no matter what the source of carbohydrates, whether it was naturally occurring sugars, added sugars, starches, the body processes it all the same way. Sugar is sugar once it's inside the body, and we need enough, but not too much. So why do we even bother to think about the source? Again, keep your eye on the big picture. Don't get so hyper-focused on a singular nutrient that you lose sight of what healthy means. When we choose foods, we want the most nutrient-dense choices. We want to get the most bang for each bite. Think of your calories as money. You want to make your limited number of dollars go as far as possible. So, when we have a diet that is full of variety, everything in moderation, balance, we're not neglecting entire food groups, we're not depriving ourselves of certain nutrients, we mix it all up, then we get the whole kit and caboodle. We get all the things that we need to be healthy. And when we're eating those healthy foods, the very nature of them is that they aren't the ones that make us want to overeat. If I give you a piece of whole wheat bread, you'll probably stop at one. If I give you a croissant, you could probably eat 5. We all know you smush a croissant down, there's not much to it, and it's good. That's because it's made of refined grains. So, here's the thought that you should have at this point. These foods, dairy, and plants contain sugars for fuel plus a wealth of other valuable chemicals. So before we conclude, I just want to touch on a few random but relevant points, things that I know are applicable to this course and to further discussion and help round out your knowledge a little bit. So the book touches on the topic of sugar substitutes. I find that people get really confused about sugar substitutes. People often ask me, oh my God, is it true that they're so horrible? There's really no hard science that says that sugar substitutes are harmful to people. We do have science where we've used animal studies and we've given animals massive quantities that are far greater than what a human would typically consume, and they've harmed the animals. But you have to remember that, we're not those same animals, so things may behave differently in our body. And you also have to remember that the quantities used in the studies are usually much greater than what we consume, because we're looking at, what does it take to cause a problem? And so therefore we can extrapolate from that if we stay below that, it's probably not as risky. But nobody can tell you 100% what the effects on humans are of sugar substitutes, because they haven't been around long enough, and not too many people want to take in mass quantities and see what happens in a study. So essentially what I'll say is this: we're all guinea pigs. If you're using them, well, in 100 or 200 years after people have been using them and we start to see people suffer and we realize those people all consumed a lot of them, I guess we'll make that connection, if there is such a connection. It really always comes back to something really simple. Everything in moderation. If you really want some sweetness somewhere and you think you can live without the added sugar, then use a moderate amount of artificial sweetener. But don't forget, the more sweetness you put on your tongue, the more you're going to have a hard time resisting that desire for sweetness. So that's a personal call you have to make. And for people who have lived a really unhealthy lifestyle, don't have a good diet at all, you can't expect extreme changes abruptly. So sometimes this is a nice way for people to transition into better habits. It has its application. And, from a cooking standpoint, the science of these substances is such that some of them do mimic sugar pretty well in culinary respects and others not so much. So you always have to do your homework and find out about the equivalent amounts if you're going to try to use one. It might alter the texture, it might alter the mouthfeel, it might alter the coloring of a baked good, for example, and it may alter the taste as well. So that's just a brief synopsis. If you want to know more, you'll have to ask. So the last thing that I want to take a few moments to address is the topic of diabetes. It's not in your book, but it's certainly relevant it is technically in your book a little bit at the end. We'll get to it later. So now is the appropriate time to bring up these details. It's just not in your book for this chapter. So again, if you're overwhelmed at this point, stop here and come back to this when you can focus, because you really do want to understand this. It will make a difference to you in the world you live in. So there are actually a number of different types of the illness called diabetes. Most of them you'll never hear of. The two types that you are most likely to encounter in the world are type 1 and type 2. If you've ever known a young person, a child, who had diabetes, that was probably type 1, because type 1 usually occurs early in life. It could technically occur in infancy. Oftentimes it occurs in kids, age 6, age 10, age 15. It can occur as late as 30ish, but usually it occurs later in life. Well, why is this? We don't really know what the trigger is. We have some ideas, and we're not going to go into that here, but what we know is that something causes the person's body to think that its pancreas, which is what produces insulin, is a foreign entity, and the body turns against itself. It says, hey, there's a foreign entity. I have to destroy all foreign invaders. And so it begins to destroy its own pancreas. When the body turns against itself, it's called an autoimmune disease. There are many autoimmune diseases. This is just one example. And when it turns against itself and destroys the pancreas, well, there's a part of the pancreas that produces insulin. And if that part is destroyed, then the pancreas can't produce insulin. Remember, insulin acts as the key to open the door to your cells so the glucose can go in. So if your body no longer makes keys to unlock the doors, then the doors will never open, which means the cells will never get fuel and the person will die. So for most of history, people died from type 1 diabetes. It is a relatively new invention to be able to keep people alive thanks to being able to produce insulin that we put into bottles and give to people. That's new within the past 50, 60 years. We first began extracting it from pigs and taking it out of their pancreas and putting it in bottles. There were problems. Most of you have heard of genetically modified organisms, GMOs. I mentioned that in the first lecture, and most of you associate them with being a negative thing because most people know very little about them. But we now genetically modify structures in petri dishes and laboratories to turn them into the equivalent of human insulin so we can put them in bottles and save lives. So there's one of the many pros to GMOs. Insulin wouldn't exist if it weren't for that. So these people are able to give themselves an injection of insulin, replacing what their body cannot make, so that their their cells can take up the fuel they need so that life will continue. It does generally require that someone learn something about food, because people have to learn that for every certain amount of carbohydrate they ingest, they need to give themselves a certain amount of insulin. So a registered dietitian like myself could teach that individual about such things. Type 2 diabetes, and I will say this twice, is what you care about. Type 2 diabetes is where our focus lies. As you can see, most of the incidences of diabetes in this country are type 2 diabetes. Type 2 diabetes is what we call a multifactorial disease, meaning there are multiple factors that come into play in order for it to develop. No one thing causes it. I would put it this way. There are many pieces of the puzzle that must fall into place. Well, if you're going to complete a puzzle, you got to have all the pieces. If you don't have all the pieces, you can't complete the puzzle, right? So if you don't want this puzzle to fall into place, and you don't, then you make sure it doesn't have all the pieces it needs. Two of the key puzzle pieces are small muscle cells because of somebody being not very active. You can change that, right? You can be more active. And too much body fat, which generally stems from not being active enough and from taking in too much food, too many calories. So we can largely control whether or not type 2 diabetes will develop based on our lifestyle. You see, there may be a trend in a family for type 2 diabetes to develop, but that trend is not that there is a gene to get the disease. The trend is that that person's body is genetically sensitive to inadequate activity and genetically sensitive to excess body fat. So while everyone may have the same genes, only the individuals who accrue excess body fat and are too inactive are probably going to end up with the disease. So one or the other, right? It doesn't have to be both. It could be too little activity or too much body fat or both. The more puzzle pieces you have, the more likely the puzzle will be complete. So we say that type 2 diabetes is a largely preventable lifestyle-related disease. It is one of the most common diseases in our country today, which is a direct reflection of the fact that our lifestyles today require so little physical activity and our eating habits are so in need of improvement. So when we look at type 2 diabetes, we cannot cure it. We can sometimes train people so well with diet and exercise, and sometimes they still need medication, that we can kind of put it in remission. It's kind of like it's not there, but if they fall off the wagon, then everything goes right back where it was. So there's no cure for it, but it can be managed if people make the necessary lifestyle adjustments. So let's walk through this very briefly so you can appreciate why these things matter. Again, you know that when we consume carbohydrate, it breaks down into these singular sugar molecules which enter the bloodstream and become known as glucose. You know that the pancreas is triggered to release a hormone called insulin, which acts as the key that opens the doors on our trillions of cells so that the glucose can move from the blood into the cell. So what if that key doesn't work? What if it's trying to insert itself into the keyhole, but it can't? Something's blocking it. There's a bunch of gunk in the keyhole. Well, if the cell is resisting insulin, we say the person is insulin resistant. You've probably heard the term pre-diabetes. That's the casual way of saying insulin resistance. So what it means is you are in the state before you actually have diabetes. You are at the point where you can throw this train in reverse. If you can undo this insulin resistance, you will not develop diabetes, pre-diabetes. Many people don't heed the warning and things progress and they develop diabetes, which cannot be reversed. So insulin resistance or pre-diabetes is a very big deal. Well, how does this happen? Think about this. If the key can't work in the keyhole, then all the glucose stays in the blood vessel, right? And that means it's bouncing around and banging on the walls of that blood vessel, and it's harming them. It also means none of it's moving into the cells. So the cells are starving. They're deprived of fuel. The body isn't functioning as well as it could. The person probably feels tired. They're probably peeing more, and then they're feeling thirstier. It's not a good state when our blood glucose is elevated for long periods of time because there's too much gunk in our keyholes and the key won't work. Well, why might the keys not be working? What is this gunk in the keyhole I speak of? And why did I say that inactivity matters? Well, let's think about it. If we're talking about muscles, we're talking about skeletal muscles, right? We're talking about all muscles. We're talking about your organs, but your skeletal muscles are an organ. The more you use a muscle, the bigger it gets. Well, a muscle's made up of cells. That means the bigger the cells get. The more doors there are on a cell, the better the chances of getting some open, right? But if the cells are small, because you don't use your muscles, you don't use them, you lose them, then there aren't that many doors. And if the keys won't work on the few doors that there are, then you're out of luck. So physical activity means increased muscle mass, which is one of the keys to preventing diabetes. And if someone has diabetes, then physical activity is one of the keys to helping manage it by improving the presence of enlarged muscle cells. What about that gunk in the keyhole? If I try to stick this key, this insulin, into the receptor site, the keyhole, and there's a bunch of gunk there, then the key's not going to work. Well, where do all of your organs lie? They're not in your butt, right? You can have a whole lot of junk in the trunk, and it doesn't alter your health. Your organs aren't down in your thighs. You can have big thighs. It doesn't alter your health. Your organs lie in your abdomen. And when I say that these keys are trying to insert themselves into your cells, I'm referring to all of your cells, your skeletal muscles, your liver, your cells that make up your intestines and your stomach and your heart and your lungs and your kidneys, all of them. And if each one of those organ cells cannot get fuel, then that organ cannot function well. That's a disease state. So when we accrue too much body fat, adipose tissue, in the abdominal region, our abdomen, what we call belly fat, it increases the likelihood of diabetes, and if we already have it, it makes it worse. So from a health standpoint, what we say to people is a pear shape, too much junk in the trunk and some big thighs, not a health risk. But an apple shape, a big abdomen, a big belly, not good. It's not about looks, folks. This isn't a vanity course, right? This is a nutrition course, and nutrition is about health. Take a moment. Oops, give me a second. So now I want you to think. The longer this goes on, the more time that goes by with all that gunk in there. Somebody has a lot of belly fat for quite a few years. Over time, that pancreas is working harder and harder. What? That key didn't work? Here, try another key. What? All right, I'll make some more. Here's another key. Well, the harder you work, the more exhausted you get, right? So imagine he's working double time, triple time, year after year after year. Eventually, that pancreas is going to become exhausted. He's going to get worn out. He's going to endure wear and tear beyond what was necessary. And when that happens, the pancreas will no longer even be able to produce enough insulin, enough keys to do what you need to do. And when that point is reached, we say, you have type 2 diabetes. So most people go through an extended period of time where their health is deteriorating. And the only way that they would know that is if they go every year for a full physical and blood work, because the blood work is what will tell us that there's a problem. We will say it looks like pre-diabetes, You need to do something to change things. So wearing out your pancreas, this is a picture of a worn out pancreas, by the way, is a pretty big deal. And so the more that we can do to eat healthfully and be active, the more that we can do not just to maintain good functioning of our body, but to preserve our quality of life. Because when we are disabled or ill, then every aspect of our quality of life is impaired. Largely preventable diseases are based on healthy lifestyles. So last little tidbit, the power of food as medicine. It's pretty darn incredible. Obviously, I'm a registered dietitian. I'm passionate about the power of food as medicine because, hey, we're a world and a culture that's all about treating illness. Well, I am all about preventing illness, and then if it occurs, fixing it as much as possible so that people live high quality lives. And so the fact that I can help someone with diabetes to be less ill and suffer fewer negative consequences is just an amazing thing to me. So we use a form of medical nutrition therapy in nutrition science, and it's called carbohydrate counting. And so the proper management of any kind of diabetes requires the assistance of a registered dietitian. So imagine that I have a person in front of me with diabetes, and I do the calculations I know how to do, and I say this person needs about 2,000 calories a day for his body to function properly and do all the things it has to do. And then I say, okay, so 45 to 65% of someone's daily calorie needs, most of their calories should be in the form of carbohydrate. Hence, this person needs a lot of carbohydrate to make sure the cells get the fuel they need. I usually am going to compromise. I'm going to probably go around 50%, not the low end, not the high end. I can tweak it down the road if I need to. So if I were to calculate that for 2,000 calories, that would tell me that the person needs about 275 grams of carbohydrate per day. So I would teach this person two things. I would teach them how to look at the nutrition facts panel and locate the total carbohydrates. I would tell the person, this line is for people with diabetes who have learned the art and science of carbohydrate counting. So what you want to do is look here and see how many grams of carbohydrate are in a serving, decide how many servings you're going to have, and that way you'll know how many grams of carbohydrate you're about to consume. Because every time you have a meal, you have to stay within a certain limit. Not too many, not too few. Your body needs a certain amount of carbohydrate consistently. So I might break it down like this. I would say, all right, of the total that you need per day, we want to divide it into equal amounts between 3 meals. That way you get the exact same amount entering your blood each time, so you get the exact same rise in blood glucose each time. Then we want to wait 4 to 6 hours before you eat again because you got to give your body time to move the glucose from your blood into the cells. And that way you create a consistent rise and fall that protects your blood vessels and doesn't damage them. So if I divided this total daily amount for this person to the 3 meals, I would realize, okay, he or she needs about 90 grams per meal. And I would say, I don't want you to only eat things that have a nutrition facts panel. I want you to eat lots of whole foods too. So I would help them understand how to estimate the carbohydrate in assorted whole foods. I might say to the person, meat does not have carbohydrates, and that includes seafood. So eat as much broiled salmon as you want. Broiled salmon's healthy for a lot of reasons, and it doesn't contribute any towards your 90 grams. You need it for the healthy fat and the protein, though. And then I would say, broccoli, green vegetables are so fabulous for your health. And so every half cup of cooked broccoli has 5 grams. A good cup of it's going to be very filling, so that's 10 grams. And then I would teach them that a cup of raw, uncooked vegetables has around 5 grams, and they could decide to have about a cup of tomato. They could take a whole tomato and slice it up, drizzle it with a little olive oil and basil, kind of caprese style. And then I'd say, what do you like? You like potatoes? Well, sweet potatoes are even better than white potatoes. You can have both, but the more color there is in your diet, the better. So how about you cook some sweet potato, about a cup worth? Every half cup has about 15 grams. So if you have a cup, you have 30 grams. And then I would say, a lot of people like rolls, but you want to make sure it's 100% whole wheat and look on the package. And so they see that one small roll has 15 grams. And they say, I want to make sure that I don't eat too many carbs with my meal because I want to save some and have dessert right away. And they look on the container and they see that one cup of this ice cream has 30 grams. So they say, all right, I'm going to let myself have cup of broccoli, a cup of tomato, a cup of potatoes, one small roll, and 1 cup of ice cream because bam, I got a bunch of healthy stuff going on here. I even get a sweet treat. I'm going to feel full and check me out. That's the 90 grams I need. They don't want any less because they won't get enough fuel, and they don't want any more because then their blood glucose will go too high. It usually takes a few hours meeting with someone for an hour or so a few times before they get the hang of it, but most people quickly do. And then they keep blood glucose records at certain times of day, and we compare that to the grams they're eating until we find what works for their body. And people with diabetes are able to go forth protecting the health of their body, minimizing the effects of their disease, and enjoying their ability to eat all foods. Hopefully, they're also focusing on healthy choices. So, again, the power of food is amazing, and hopefully you're beginning to see that, and instead of focusing on all the fears about food that surround us in society, you're starting to see that it's the quality of our choices that matter, and there is room for freedom. And if we don't look at it as deprivation when we limit things, and we instead get excited about what we are doing for ourselves, then food is still a joyful part of our existence. So we've come full circle, guys. At this point, you should feel like you know what is not correct, that there's no food group called carbohydrates, that all sugar is not bad for us, that sugar does not cause diabetes, and that people with diabetes can eat everything if they know how to do so. As always, I welcome your questions.